Hello and welcome to another video for pre-calculus. In the last video, we talked about trigonometric functions using the right triangle. So now in this video, we're going to look at the same thing using the unit circle. So first of all, a unit circle is a circle with radius 1, and then this is a special case, so center at origin. So that is the unit circle. So let me draw that. So, okay, that's not a straight line. So let me draw a unit circle. So circle center at origin. It's not perfect, but yeah. So circle center at origin and the radius 1 is called the unit circle. Now the equation of the unit circle is x squared plus y squared equals 1. So if I pick a point here, x comma y, and then if I complete a right triangle here, and if I say this angle is theta, then I know that this is x, this is y, this is 1. Now using Pythagorean theorem, I have x squared plus y squared equals 1, which is the equation of that circle. Now if I use that right triangle and if I find sine theta, so sine theta from the right triangle approach, if we remember from the previous video, so sine theta equals opposite over hypotenuse, or y over 1, which is just y. That's why sine theta equals the y coordinate on the unit circle. Now if I pick any point on the unit circle, okay, and then if I draw that line and if I make an angle, so sine of whatever this angle is, okay, whatever that angle is, equals to the y coordinate on the unit circle, and that's true anywhere on the unit circle. Similarly, if I have to find cosine theta, if I use that triangle, then cosine theta is adjacent over hypotenuse. So adjacent is x over hypotenuse is 1. So which is x over 1 or just x. That's why cosine theta equals x. So similarly, we can find the other 4 trigonometric functions, or we can just say, okay, tangent is sine over cosine, y over x. Cosecant is the reciprocal of sine, so 1 over y. Secant is reciprocal of cosine, so 1 over x. And the cotangent is reciprocal of tangent, which is x over y. So we can find all other ratios once we have sine and cosine. So in a unit circle, the one that we are going to see in the next page, I have the unit circle with all the values written down for the special angles. The special angles in the first quadrant we have already looked at in the previous video in the table, but now we are going to look at all the special angles in all 4 quadrants, okay, in the unit circle, and we will look at those values. So that's what we are going to look at next. So this is the unit circle. This is very strong and very powerful tool for trigonometry. You need to keep this unit circle throughout this all other chapters that we are going to see. You are going to use this a lot. You are going to remember values. As you do, you start remembering values, okay? And then we are going to use this a lot. This is, again, this is one of the strongest and very important tool in trigonometry. So a couple of things here. So let's say we can say, okay, so sorry, we can say this is the x-axis, okay, and then this is the y-axis. So if we put this unit circle in the coordinate plane, so this is the y-axis and that's the x-axis. Now we have the quadrantal angles, which is 0 degree, 90 degrees, 180 degrees, 270 degrees, and then when you come back to 0, that is 360 degrees. And if you keep going on, you keep adding the angles, and then we can go as many revolutions as we want, okay? Now also in terms of radian, as I said, we will use a radian a lot, especially when we move on to calculus. So 0 radian, pi over 2 radian, pi radian, 3 pi over 2 radian, and when we come back to 360, so that is 2 pi radian, okay? So that's how this is, we use radians, that's how we use radians, okay? Then we have those special angles that we saw in the previous video, 30 degrees, 45 degrees, 60 degrees, 90 degrees. We didn't look at this one, but we have a special angle, the corresponding, so angles here in the second and third quadrants, okay? Another important thing, you know that in the first quadrant, both x and y coordinates are positive. So we have both positive, positive in quadrant 1. In quadrant 2, x coordinate is negative and y coordinate is positive. In quadrant 3, both both coordinates are negative, and in quadrant 4, x is positive, y is negative. So that's what you see in that in those squares over there. Okay, so let me actually erase all of this, and then we'll talk more about that. Excuse me. So now what we need to do, what we see from here is we have those values, and I gave you a technique to write the values for 0 to 90 degrees, right? 0, 30, 45, 60, and 90 degrees. In the previous video, we look at the table. Now, here, if you look over here, so 0 degree, so we have a coordinate here. This coordinate is 1, comma 0. X represents, remember, from the unit circle, the definition we have looked at, sine theta equals y and cosine theta equals x. That means if we pick a point here, which is this point, okay, x value represents the cosine of that angle, whatever, 30 degrees, and and then sine theta represents that angle, okay. So now let me go back, and what we did in one of the previous video, we used the right triangles. Remember, we used that equilateral triangle. Remember, if you remember that 1, 1, 1, and then I said we draw a perpendicular. This angle is 30 degrees, this angle is 60 degrees, and this is a square root of 3 over 2, this is 1/2. We did that, okay? Now if you bring this triangle and if you place it here in the unit circle, so this is 30 degrees, that means this vertex is right here, 30 degrees, okay? And then this is the y, this is the perpendicular, okay? No, or the if you rotate that triangle, so this becomes square root of 3 over 2, which is this one is square root of 3 over 2. So we have that triangle right here. Okay, I brought that triangle and put it here. And then this is 1/2. Okay, so 1/2 goes here. This side comes down here. And then this 1 is the hypotenuse right here. This is 1. Now this point is x comma y, x comma y. So it's exactly the same thing that we did with the right triangle, okay? We are just putting that right triangle here in the unit circle. We are fitting that here, and then we have the same value. So now for sine 30 degrees, we have 1/2 or y value, and for cosine 30 degrees, we have square root of 3 over 2. That's exactly what we got when we used that right triangle, okay? So now all the points here in the unit circle, x represents cosine of whatever that angle is, y represents sine of that angle. Now if you look over here, so if I want to find what is sine of 330 degrees, then I have to go to 330 degrees and I have to look at my y coordinate. It's not showing up here, but this is 1/2. So my y coordinate here, and that gives me the value for sine 330 degrees. Or if I want to find what is cosine of 210 degrees, then I go to 210. Cosine means the x value, so it is negative square root of 3 over 2. Or if I want to find what is sine of 3 pi over 2, then I go to 3 pi over 2. Sine means the y coordinate, so it's negative 1. So that's how we use the unit circle. Now if you just remember the values in the first quadrant, then we can find any other values. So for example, so if you remember these 6 values, okay, so 1, 2, 3, 4, I mean 5 values. Those 5 values for sine and cosine, if you remember that, and remember I showed you a way to write your own table for that, okay? So if you remember those values, now you can find the values for any other angles in that unit circle. Before I show you that, let me tell you one more thing, okay? The other thing is just looking at this sign. So both are positive here, x and y are positive. If both are positive, then all the values, sine, cosine, tangent, cotangent, all 6 functions are positive in the first quadrant. So all positive in the first quadrant. Now, if you look at the second quadrant, we have the x negative and y is positive. Y means sine, so that means sine is positive. Negative, so x means cosine, so cosine is negative in the second quadrant. Now, from there, the reciprocal of sine is cosecant, so this should be positive because sine is positive. Reciprocal of cosine is secant, so since cosine is negative, secant must be negative because the reciprocal is obviously negative. Now, if you look at other functions, so we have tangent. So tangent is sine over cosine. So positive divided by negative. This is also negative. Now, if you look at cotangent, it's the reciprocal of tangent, so obviously that is negative. That means in the second quadrant, we just have sine and cosecant positive, all other four ratios are negative. So all positive. Now I have a small sentence that I use to remember this. Okay, all students take calculus. All positive. S means student, so S means sine is positive, and if sine is positive, obviously cosecant is positive because it is the reciprocal, but all other four ratios are negative in the second quadrant. Now, if you go to the third quadrant, take means t, so tangent is positive. So these are for positive, and the remaining are negative. Okay, so tangent is positive, but obviously if tangent is positive, cotangent must be positive because it's just the reciprocal. Now sine, cosine, secant, cosecant, all those four ratios are negative in this third quadrant, because if you look over here, both are negative. So cosine is negative, sine is negative. Cosine negative means secant is negative. Sine negative means cosecant is negative. But tangent is negative divided by negative, which is positive. That's the reason that tangent is positive in the third quadrant. Similarly, when you move on to the fourth quadrant, cosine is positive, sine is negative. So if sine is negative, then cosecant is negative, tangent is negative because tangent is sine over cosine, and the cotangent is negative. So the only that is positive here is cosine and its reciprocal, which is secant. That's why C calculus means cosine, and the reciprocal of cosine is secant. So the summary is, in first quadrant, all functions are positive. In second quadrant, sine and cosecant is positive. All other four, they are negative. In the third quadrant, tangent and cotangent are positive. All other four are negative. In the fourth quadrant, cosine and secant is positive. All other are negative. Okay. So now once you remember that and you remember the angles in the first quadrant, now how to find the other angles without remembering them from the unit circle. So for example, let me give you one example. Okay, so I want to find the value for 240 degrees. So let's say sine of 240 degrees. The first thing that you are going to do is you are going to find the reference angle, and we talked about that in one of the videos, in one of the previous video. Okay, so reference angle is the acute angle made by the terminal side, with the horizontal axis or the x-axis, so this angle. So we know that 240 is in the third quadrant, so to find the reference angle, you subtract 180 from 240, and that gives you 60 degrees. So the reference angle is 60 degrees. Now what I do is, I'll use the angle from the first quadrant, so I know the value of 60 degree sine 60 degree is, so if I go to the 60 degree and find the y value, so it is square root of 3 over 2. But we are finding the value in the third quadrant. 240 is in the third quadrant. I know that in third quadrant, sine is negative. Only tangent and cotangent are positive. So that means this must be a negative value. So if you go back and check here, sine 240, negative square root of 3 over 2. So for example, let me give you one more example, okay? So if you want to find cosine of 150 degrees. Now go ahead and find the reference angle for 150. So for the angles in the second quadrant, the reference angle is given by 180 minus whatever that angle is, and here it is 30 degrees. Now what I do is I look at the cosine 30 degrees, okay? So I go to the first quadrant, I already know the value, so cosine 30 degrees is square root of 3 over 2. But now cosine 150 is in the second quadrant. I know that in second quadrant sine and cosecant are positive, but rest of them are negative. That means cosine is negative. So the value of cosine 150 degrees same as 30 degrees, which is square root of 3 over 2, but since it's in the second quadrant, it must be negative. So that's why I have that value over here. So likewise, you can find any values either in the fourth quadrant, third quadrant, or second quadrant. If you just remember these 5 values, you can use them to find all other values, okay? You just have to do a couple of practice. You just have to play with this one. Just print this one, keep it with you when you're doing problem, and just play around with this. You will remember those values, and you will be able to find the values. But we will be using this a lot, so make sure you have that in your hand all the time when you're doing the problems, okay? When you're doing homework or any other problems. So we are going to use the unit circle, and we are going to find the values for this angle. So in case if you, so since if you look over here, the values, the angles that we have are from 0 to 360 degrees, okay, all positive angle. We can go in the reverse direction, and then we can find the negative values as well. Like for negative 120 means if you go in this direction, negative 120 degrees, same as 240 degrees. You can use that. But if you are still confused with this negative angle, what I suggest you to do is find the coterminal angle. Remember in one of the examples that we did in the one of the videos is find the smallest positive coterminal angle. So that's what we are going to use here, okay? So find the smallest positive coterminal angle for the given angle. If it is not in the range 0 to 360, okay? If it's not in that range, then find the smallest coterminal angle. So here 120, so if you find the coterminal angle of 120, that means if you add 360, you get 240. So this is same as sine 240. Now you know you will find this one in the unit circle, which is negative square root of 3 over 2. Okay, again 240. If you don't want to look at it, if you want to use the first quadrant angle, I already showed you how to do that. Find the reference angle, find the angle in the first quadrant. It is sine, so it has to be negative in the third quadrant, and then you can find that way as well. Okay, so 570 degrees, same thing. Find the smallest positive coterminal angle. That means if you subtract 360 from here, you get cosine of 210 degrees. Now you can find this angle in the inner circle. So cosine of 210 degrees is negative square root of 3 over 2. Similarly, tangent of tangent of 150 degrees is, you can look at 150 degrees right here. Okay. Now the tangent is sine over cosine. So 1/2 divided by negative square root of 3 over 2, which is negative 1 over square root of 3. Okay. Now, the next one is cosecant of 225 degrees. So cosecant is the reciprocal of sine. So first go ahead and find the angle 225 right here. So the sine is negative square root of 2 over 2, but cosecant is the reciprocal of sine. So it's negative 2 over square root of 2. Similarly, secant negative 150 means find the coterminal angle. So if you add 360, you get 210. So this is same as secant 210. Now go ahead and find 210. Secant is the reciprocal of cosine. So cosine 210 is negative square root of 3 over 2. So the reciprocal of that is negative 2 over square root of 3. Okay. And then similarly, cotangent 540. So find the coterminal angle. So if you subtract 360 degrees from here, you get cotangent of 180 degrees. Now, go ahead and find 180 degrees is the x value is negative 1 and y value is 0, or cosine is negative 1, sine is 0. Cotangent means cosine over sine, or the reciprocal of tangent, which is negative 1 over 0. So negative 1 over 0 is undefined. So this value is undefined. We cannot find that. So that's how we use the unit circle to find the values of different angles. Even if they are not in the unit circle, we can find coterminal angle, and then we can find the values. Now, if you have any other angle than that we have in the unit circle, like for example, if you have 18 degrees, so in that case, we cannot use the unit circle. For that, we have to use the calculator. So I'll probably make a separate video for using a calculator to find these values, but you can just plug this into your calculator. Make sure it's in degree mode if your angle is in degree. If it's in radian, make sure that mode of your calculator is in radian. You can just plug it into your calculator, and then you'll be able to find the values. Now, a function there's a function called periodic function. So periodic function is a function whose value repeats after a certain period. So for example, if you go over here, so if I take 30 degrees, so sine of 30 degrees is 1/2. Now if I go one full round and come back here, this is 390 degrees, right? So 360 plus 30. But the value of sine for that angle is 1/2. Now if I go one more round and come back, I have larger angle, but the values is still same. That means every after 360 degrees, okay, when I go through 360 degrees and come back to the same terminal point, I'll have the same value for the sine function, okay? But yeah, if I keep going around and around, I still get the same function. That means sine function is a periodic function because it repeats at an interval. So for example, day and night are periodic function. Seasons are periodic function. After a year, we get the same season. Or yeah, day and night. This is a periodic function because every 24 hours we get the same time. Uh, so that's a periodic function. Okay. So similarly, these cosine and sine functions are periodic function because sine every after 2 pi. Okay, when you go through 2 pi, we get the same value for sine, and it's true for cosine as well. So sine and cosine functions are periodic function. And the period is the time when it comes back to the same point or same value. So for example, for sine and cosine, we come back to the same value after 360 degrees or 2 pi radians. That means one complete revolution or one complete rotation. So that's what that period is. So for sine and cosine, the period is 2 pi, okay? Now, there's even an odd properties for sine and cosine function. We know that a function is odd function if we have f of negative x equals negative f of x, like x cubed. If I replace x with negative x, then I get negative x cubed. See, this is an odd function. Now, even function, so this is odd. We discussed that in algebra. Now, even function is if we have f of negative x and we get just f of x. For example, if we have x squared, okay, now if I replace that with negative x, I still get x squared, the same function here. So those functions are even function. Now, of those six trigonometric functions, sine, cosecant, tangent, and cotangent are odd functions. So for sine, if you have sine of negative theta, it's negative sine theta. Cosecant of negative theta, negative cosecant theta. Tangent of negative theta, negative tangent theta. And cotangent of negative theta is negative cotangent theta. But cosine and secant, they are even function because if we take cosine of negative theta, you still get the same as cosine theta. And secant of negative theta, we get the same as secant theta. So these two are even and the rest four are odd functions. Now, in trigonometry, those identities, there are some trigonometric identities that we'll use a lot, and these are very important things. Okay, so the basic identities that we are going to look over here, and we'll add more and more as we move forward. So the basic one, the first six identities are the reciprocal identities. So we know we already have seen this one. Sine is the reciprocal of cosecant, or cosecant is the reciprocal of sine, vice versa, right? Similarly, cosine is the reciprocal of secant, or secant is the reciprocal of cosine. Tangent and cotangent are reciprocal of each other. So those are the reciprocal identities. This is useful when if you know secant, then you can find cosine, or if you know cosine, then you can find secant. So similarly, if you know cotangent, you can find tangent, and if you know tangent, you can find cotangent. Similar cases with sine and cosecant, okay? Now there's another identity which is quotient identity. So if you divide two ratios, you get the third one. So tangent is sine over cosine, and cotangent is cosine over sine. So these are the two quotient identities. The other useful and very important identities are the Pythagorean identities. So if you have sine square theta plus cosine square theta, no matter what that theta is, whatever that angle is, this is always going to be 1. Okay, we can easily prove that even using the unit circle, because in the unit circle sine means y, so y squared plus cosine means x is squared. It's a unit circle, so we know x squared plus y squared equals 1. That's how we can prove. Or using the right triangle, we can prove this one, because from the right triangle sine theta is opposite over hypotenuse, and if you square that, plus cosine is adjacent over hypotenuse, if you square that, so we get O squared over H squared plus A squared over H squared, and then common denominator is H squared. Now O squared plus A squared. That means opposite square plus A squared is this hypotenuse square using the Pythagorean theorem. So hypotenuse squared equals A squared plus B squared. So that means the numerator is h squared, denominator is h squared, they just cancel out and we get 1. So that's how we can prove this one, okay? So always if you have like, if I have sine is squared of 30 degrees and cosine is squared of 30 degrees, then I can write 1. So this is always true. Now with that identity, we have two more equivalent form. Okay, this is very important. So you just have to remember actually this one, and from here you can find these two other identities. Because now from here, if you solve for sine squared theta, that means if you subtract cosine squared theta, you get this one. Now if you solve for cosine squared theta, or if you subtract sine squared theta, then you get this one. Okay. Similarly, the other, so sine and cosine are connected by that Pythagorean identity. Now, tangent and secant are related with that Pythagorean identity. Okay, so 1 plus tangent square theta equals secant square theta. We're not going to prove this, we'll just use it. If you want, you can just use the right triangle concept that I just showed you for the first one. Okay. Now, if you subtract tan squared on both sides, then you get 1 equals secant squared minus tangent squared. That's another equivalent form of that one. And then if you uh, uh, solve for tangent square theta, if you subtract 1, then this is what you get. So these three are equivalent form. Similarly, cotangent and cosecant are connected, or they are related in terms of Pythagorean theorem, okay, or identities. So these are the main three Pythagorean identities, and then from there you can find these other six Pythagorean identities. So altogether we have 9 Pythagorean identities. These are very important. You need to remember these. We'll use this a lot, not only just for this class, but for the higher level as well. So you need to remember these identities. Now let's use some of those identities that we just taught in order to find the values of some trigonometric functions here. So now this one says use the reciprocal identities to find the values of the given function. So we are given sine theta equals 5 over 6, and we are asked to find the cosecant theta. We know that cosecant theta is the reciprocal of sine theta, which means the value is just the reciprocal of whatever the sine value was. So it's 6 over 5. Similarly, we are given tangent theta equals 7, and we are asked to find cotangent theta. So we know that cotangent theta equals 1 over tangent theta. Is the reciprocal. So 1 over tangent means 1 over 7. So that means cotangent theta equals 1 over 7 theta. I mean 1 over 7. So that's the value for cotangent. That's how it's useful, those reciprocal identities. Okay. Here we are going to use the Pythagorean identities to find all 6 trigonometric functions, given that cosine theta, and then we have said that sine theta is positive. Okay. So now first we'll find sine theta. Given cosine theta, we can find sine theta using the Pythagorean identity. We have this one. Okay, so sine square theta plus cosine square theta equals 1. So this is the relation that we have. So always, if you are given cosine and asked to find sine, or if you are given sine and you're asked to find cosine, in those cases, okay, you have to use the Pythagorean identity, because that's the only identity that we have that connects sine and cosine, or that builds a relationship between sine and cosine. So now if you have to find, so we are given cosine theta, we want to find sine theta. So if you want to find sine theta, then we can solve for sine. Okay, so if you subtract cosine on both sides, you get sine squared theta equals 1 minus cosine squared theta. And this is one of the equivalent identities that we looked earlier. Now, to find sine theta, I have to take the square root, because I want just sine theta, not sine square theta. So if I take the square root, then I have sine theta equals square root of 1 minus cosine square theta. Now here you have to be a little bit careful. So we could have both positive and negative value here, but our question says we want the positive value. Ignore the negative. That's what the question is saying. So what I'm going to do is I'm going to ignore the negative value. I'm just going to take the positive value here. Okay, so this equals positive square root of that one. Now I have cosine theta. All I need to do is just plug that in here and find the sine theta. So sine theta equals square root of 1 minus cosine squared. So if I square this, I get 2 over 9. And then that gives me sine theta equals, so 9 minus 2, 7. So square root of 7 divided by square root of 9, which is 3. So I have sine theta equals square root of 7 over 3. And then I have cosine theta equals negative square root of 2 over 3. Now just using this, we don't have to again use the Pythagorean theorem. If we know sine and cosine, then we can find all other ratios. You already know that. So the cosecant is the reciprocal of sine. So we can find cosecant equals reciprocal of sine. So cosecant theta, you cannot just write cosecant, okay? Cosecant theta equals reciprocal of sine, which is 3 over square root of 7. And then from here we can find secant theta, which is the reciprocal of cosine. So secant theta equals reciprocal of cosine. So we still have negative 3 over square root of 2. We have this one. Now to find tangent, it's just sine over cosine. So we use the quotient identity. So tangent is this one divided by that, which gives us negative square root of 7 over square root of 2. Or we can put these two together and we can write negative square root of 7 over 2. Now cotangent is just the reciprocal of tangent, so which is negative square root of 2 over square root of 7, or if you want, you can put those two together. So we got all 6 ratios. Once you know sine and cosine, rest of them are easy. You can just use the reciprocal and the quotient identity. The challenging part is to find sine and cosine, and we use this Pythagorean theorem right here to find sine and cosine, okay? So that's all for this video. We'll talk more about other things in next videos. I'll see you again in the next videos.